section 3.5, page 3. We are going to start today finding the equation of a tangent line to the secant function where x is equal to pi over 4. When we want to write the equation of a tangent line, start by setting this up: y minus something equals slope times x minus something. Some of this we know already. X is pi over 4, so we can plug that in. Over here, that's going to be the y value of the function, or the function evaluated at that x value, so f of pi over 4. And here is slope, which is f prime at pi over 4. When we look back at what is our function, find the equation of a tangent line to the secant function. There's your function. So f of x is equal to secant x. And when we evaluate that at pi over 4, that's the secant of pi over 4. Thinking back, unit circle, pi over 4 is right here. Square root 2 over 2, square root 2 over 2. Secant there, the reciprocal of cosine. That is just square root 2. There's your y value right here, square root 2. To find the slope, we'll need to find f prime of x. And the derivative of secant is secant x tangent x. So plugging in then and evaluating f prime at pi over 4, that's the secant of pi over 4 times the tangent of pi over 4, which is square root 2 times 1, or square root 2. And there's that slope, square root 2. And we have our tangent line. Looking at this next one, it's going to be a little bit tight space-wise, so write tiny. We want to find the equation for the tangent to y equals 1 plus square root 2 cosecant x plus cotangent x at point P, and the horizontal tangent at point Q. When we look at the scale that was given to us, x is a member of the set between negative pi over 4 and 5 pi over 4. So here's negative pi over 4. There's 5 pi over 4. So we must be counting off by pi over 4s. And in the y's, y goes between negative 1 and 7. Negative 1 to... Okay, clearly then we see that P is at pi over 4 comma 4. So when we want to write the equation of the tangent at P, which we can read the coordinate then as pi over 4 comma 4, when we sub in y minus, okay, we know the y value, 4, is slope, we're going to have to figure that out, x minus pi over 4. Right here is going f prime at pi over 4. Let's find that derivative. The derivative of 1 is 0. Square root 2 cosecant x. Well, the square root 2 is a constant, so that just comes down. And then the derivative of cosecant is negative cosecant x, cotangent x, and then plus the derivative of cotangent, negative cosecant squared. Be careful here that you read this as times negative cosecant cotangent, not minus cosecant cotangent. When we clean this up a bit, we'll have negative square root 2 cosecant x cotangent x minus cosecant squared. Notice the notation now. We're going to evaluate at pi over 4, negative square root 2, cosecant pi over 4, cotangent pi over 4, minus cosecant squared pi over 4, negative square root 2. Cosecant of pi over 4, we can look back at this unit circle, and the cosecant of pi over 4 is square root 2. Cotangent of pi over 4, cosine over sine, that's 1, minus cosecant squared of pi over 4, so we'll need a square root 2 squared. And we'll have a negative 2 minus 2, which is negative 4. There's the slope. Goes all the way back up here, negative 4. All right. Now, part B. We want to find a horizontal tangent. A horizontal tangent occurs when f prime of x is equal to 0. And we want the horizontal tangent at Q. Yes, you can read the ordered pair there, but I do want to do this problem as if you couldn't read that ordered pair, or it was some ugly value that you had to figure out on your own. So again, that's what I'm going to do, is I'm not just going to read this coordinate, I am going to go through as if we couldn't tell what that coordinate of Q was. So we'll set f prime of x equal to 0. So right here, there's f prime, negative square root 2, cosecant x, cotangent x, minus cosecant squared. Set that equal to 0. Remembering your pre-calculus, to solve this equation, we'll have to factor out a cosecant. Oh, and since both are negative, let's factor out a negative cosecant. That'll leave us with square root 2 cotangent x plus a cosecant x equals 0. Then zero product property says one of these pieces has to be 0. So we'll say negative cosecant x equals 0. Or square root 2 cotangent x plus cosecant x equals 0. Cosecant is 1 over sine. When we think about this, the only way a fraction over here can equal 0 is if the numerator is equal to 0. That numerator can never equal 0, so that piece has no solution. This one over here, again, if we change anything into sines and cosines, we'll have square root 2 cosine x over sine x plus 1 over sine x equals 0. Combining these two fractions, and again, the only way a fraction can equal 0 is if the numerator is equal to 0. So that means that square root 2 cosine x plus 1 has to equal 0, which means cosine x is negative 1 over square root 2. When we rationalize, cosine is equal to negative square root 2 over 2. And thinking back to the unit circle, where is cosine negative square root 2 over 2? It's right here at 3 pi over 4. 5 pi over 4. Okay, clearly looking back at the graph, that has to be 3 pi over 4. If this were an uglier answer, you could kind of figure out which one of these is numerically in that neighborhood. So for our purposes, x is 3 pi over 4. So Q now is at 3 pi over 4, comma, something. And you can figure out that something by evaluating the original function at 3 pi over 4. And that is 1 plus square root 2 cosecant 3 pi over 4 plus cotangent 3 pi over 4. We'll have 1 plus square root 2 cosecant of cosecant of 3 pi over 4 is positive square root 2. Cotangent of 3 pi over 4 is negative 1. Negative 1 and 1 subtract out, so we are left with 2. There's the y coordinate for Q. Not done. The last thing that we need to do is actually answer the question, which is to write the equation for the horizontal tangent at point Q. Horizontal tangent is a horizontal line at 2. Again, we knew that initially because we can read the coordinates there at 3 pi over 4, comma 2, but I went through this work to refresh your memory on some pre-calculus and also to help you if you get stuck on some of the homework on finding coordinates when they're not given to you.